Now let's do some practice questions from chapter 3. But before we start, let me mention two things. So first, from Husky City, you can actually access the solutions of each chapter, right? It's actually here partial solutions. Uh, there is no like a detail, within here, but at least you can see from here the end result for each question, right? Um, I'm not sure whether you can get the solution menu. It says here the um, solution menus are actually free. You can download from here. Try, okay. So if you can download the full version, that's better. If not, at least once you finish each question, you can compare your result with those here um, to figure out whether you get everything correct or not. That is the first thing. Another thing I want to mention is in the course content, I added a quick thread. Here I found it a nice menu written by Samuel from the University of Toronto. So basically here it's quick instructions on how you can use, this is a special calculator, so it's Texas BA2 Plus. This tells you, how you can calculate the important, let's say, PV, FV, um, time periods N, or interest rate, etc. Right here, you have the examples. You may have a different calculator than the one showing here, but the basic things should be the same. For instance, what I have is what it's called. It's similar to BA2 Plus, but it's a professional version. It comes with this kind of menu you can always download from your manufacturer. It shows pretty much everything you need to know about this calculator, right? About this course. There are many useful functions you need to know from this menu. So get a calculator and study the menu on your own. I really think you should be able to understand the things from the calculator menu. Okay. Now let's do the practice questions. Let me get the pen ready. Okay, so the first one we have is 3.1. Okay, let me connect my pad. So 3.1 is Max receives 300 in 1 year, 350 in 2 years. So basically, we would want to draw a timeline to help us understand. So as you can see, the amount goes up by $50, and it ends at final payment $800. So first you need to figure out the time point, right? The end point would be 11, right? That is because 800 equals, the first one is 300 plus the increment is 50 times this n minus 1. Minus 1 is because this 300 is paid at time 1. So from there, you easily see n should be 11. By the way, this is the general formula for arithmetic sequence. I want to know the present value. So obviously, this is an increasing annuity immediate, but this is not a standard one because I cannot factor out 300 to get it to 1, 2, 3, 4, all the way to 11. Since I know the increment is 50, so I know how to do the decomposition, right? You do for the beginning one. So the first one is 300. The second one would be 250, and here is 100. 100 would be 50 times 2. Goes away. Here is 250, obviously 50 times 11, right? So the present value of this special annuity would be, this is a level annuity immediate for 11 years. Then I have an increasing annuity immediate also for 11 years, right? And then it's plug in formula to do the computation. Check your result with the one you can find from the end of the book. 3.4, we actually need information from 3.3, so I read 3.3. Kendra receives 900 now, 900 now, 970 in 1 year, 1,040 in 2 years, and so on until 1,600. So how do I figure out the time point? It will be 900 plus. The increment is 70. I need to know n minus, here is not 1, it's 0, because 900 is paid at time 0, not time 1. Okay, it's clear that is, well, that is 10, right? 1,600 minus 900 is 700. 700 divided by 70 is 10. So here it's 10 years. Actually, it's 11 because this is an annuity due, but that's okay. Again, this is non-standard one, right? So we already know from the first one how you can decompose. We know the increment, just leave the increment for the first one. And whatever left would be the level payment, right? Here it's 830. Right? If you do the subtraction, it will give you 140. 140 is 70 times 2. So here you will go to the very end. Okay, you get 11. So here we want to know the future value at time 11. Okay, because this is an annuity due, it has 11 payments. So the level 1, because we want future value and because this is an annuity due, so put double dots. So S double dots, angle 11, right? Because there are 11 years, 11 payments. Interest rate is 9%. So I can put I, it doesn't matter. So I can factor out 70 is the increasing annuity due for 11 years, right? So from this, we have the formula. So complete this, okay? I actually want you to actually compute all the final result because this helps you to reuse everything we already derived, right? The formulas of IS, the formula of DS, etc. 3.7. So in this case, road receives annual payments beginning with first $50 today. Each subsequent decreases by 10. So the next one will be 40 until time 4 years. Okay, what would be here? So 1 minus 0 is 1, then decrease by 10. 4 minus 0 is 4, decrease by 40. So here I have $10. And then each subsequent increases by 10. Interesting. And until the last payment at 8. Okay, I need to figure out the distance. So it's 4 years. So we'll increase by 40. Then I will have $50. So, you see, it starts with 50, decreases to 10, and then goes up back to 50. Interest rate is 5%. Determine the present value of payments at time 0. The easiest way. Right, because they are only limited case. $640 is 7, 50 is 8, right? So it looks like a dumb method to write everything down and do the summation. But in this question, it might be the smartest method to get it finished because write it down, it's simple. Right? It doesn't even take you any effort. I write it down because I want to show you. Right? If I have a calculator, I simply hit all the buttons. I don't even need to draw the timeline. If you are sophisticated enough, you can process this information in your brain and using your calculator, I think you should be able to get this result in 30 seconds, right? And that is the best way. But here, of course, I'm not actually promoting this. I'm trying to analyze. This part is actually easy to do because it's 5, 4, 3, 2, 1. So it's decreasing. What do I need? I need present value. So it's dA. So this part is easy. Okay, it's simply factored by 10. It's a standard decreasing annuity. It's actually annuity immediate. An annuity due, excuse me, because the first payment is at time 0. What's more complicated is how are you going to handle this? 20, 30, 40, 50. There are, of course, there are only 4 of them. You can do this if you want. It's an increasing sequence, right? But it doesn't start with 10. So let me borrow 10. Okay, this is imaginary. So if I put that, what I have? Okay, so for 5 terms, I don't exactly have that blue $10 at time 4, so I will need to subtract it, right? I directly subtract 10 because this present value is at time 4, right? It's at the same time point, so I can do the subtraction. That's not finished yet, right? Because this is the value of those payments at time 4. I want my present value at time 0. So let's do a proper discounting for 4 years, right? After that, then you get everything, right? From there, I can apply the formula for DA. I can apply the formula for IA. Actually, the issue is here, right? Otherwise, without this IA and DA, they give you a standard level annuity, right? But anyway, you can continue from there. 3.9. A bank is offering a special deal if you invest X dollars now. So this is the present value. The bank will give you 15K at time 7, 14K at time 8. So it goes down by $1,000, and so on until time 14. Okay, what would be the payment? So 14 minus 7 is 7. So you go down by $7,000. So in the end, you have $8,000 at time year 14. Interest rate is 8%. Determine X. Okay. For this, we have done this quite enough, right? The decrement is $1,000. So it's easy to figure out the decomposition, right? So here it's 7K, so it's actually 1K times 7. So it's 7K, 1K times 8. Okay, well, it depends, right? You can treat this as annuity immediate, or you can treat this as annuity due. So let's treat it as annuity immediate. So it's paid at the end of each year. So I have level payments for $7,000. It lasts for 8 years. Right? Of course, you can count from 7 to 14, right? But in total, we have 14 years. The first 6 years, there are no payments, which means I have 8 payments in the remaining years. Okay, and 1,000, let's factor it out. This is a decreasing annuity immediate for 8 years. Okay, of course, that is not done yet, because once I do everything, I get to the point, the starting point of those 2 annuities, right? In order to go all the way to time 0, discount by 6 years. This is the present value of all the payments. That is exactly the amount you are supposed to pay to the bank. Next one, 3.12. Calculate the accumulated value at time 10 years that is received continuously over each year. Over 10 years, In the first year, the payment is $200 in the first year, and then decreases by $15. So the next one will be $185, goes on until the very last one, until the last one is until the very last one. It's not 10. I'm not sure why I put 10 down there. It's the question says the last payment is is $80. So we actually need to figure out what would be the last time point. All we know is $80. Okay, so the difference between 80 and 200 is 120, right? So you need to use one until the last payment of, oh, it's nice here. There's nothing you need to calculate. They actually gave you. So by the way, if you want to calculate it, it is the difference divided by. So it's 8. Okay. So that's also the reason why this is 9, because the first year you have 200. So the ninth year you should have 80. Okay. The annual effective interest is 4%. We want to know the accumulated value at 10 years that I received continuously over time. Okay, so there are many different ways you can do. Right, one of the things you can do is you can actually analyze one by one. Right, for instance, this is 200. Right, so we want from T to the accumulated value at time 10 years. Okay, at time 10 years of the payment that I received continuously over each year until the last payment is in the 9th year. Okay, so this is what you can do, right, for continuously for each one. I'm not sure why they put 10 years for each year, and they say the last payment is received in the 9th year. Huh. I mean, we can calculate 2 times 10, but it seems there's some error with the question. It should be at time 9. Okay, so let's do timeline. So this is for the first payment, 0.04 ds dt, right? And then you can add the second payment, until the very last one. Okay, but of course you can do the decomposition, right? It's very routine, right? You know the decrement is 15, so you start with the smallest one. So you know this is 65, right? You go back, this is 65, 50 times 9, right? And then you have a level continuously payable annuity. Then you have decreasing, so basically a 65. This is a level, so it's S bar because this is continuously payable. Then I factor out 15. This is a decreasing continuously payable for 9 years, right? So once you have done enough, you can easily see the decomposition at this moment. Brian turns 25 years old and would like to receive inflation-adjusted payments on his birthday. There are when a question involves somebody's age, there are 2 different ways to mark the timeline. One way, okay, so one way what I usually do is, this is the starting point. Brian turns 25 years old, which means is at the last day of 24 and the first day of 25, right? Because in our notation, we usually use that number to mark the end of that year. So here 25 means the end of 25 years. So Brian just turned 25 years old. That means he's having his first day of the 25th year. So that's why I mark it at the end of 24. Okay. For the same reason, we want the payment to start at 64 all the way to 94. So how many payments? So do the subtraction. It's 30, 30 plus 1. So we have 31 payments. Right. So again, it's either the difference or difference plus 1, right? So at 64, you have the first payment. 64 minus 64 is 0. At 0, you have the first payment. So you have to use the difference plus 1. That's why I have 31 instead of 30. Okay. Inflation corrected. What does that mean? Or inflation adjusted. That means the first payment is, what is the first payment? First payment here is 100K. That's generous pension. The Brian wants the payment to be inflation adjusted, and inflation is 2%, which means next year he wants to receive 2% more, right? That's called inflation adjusted, because with this increment, his net adjusted income is the same, $100,000 in purchasing power. Okay, so that is compound increase, right? So for compound increase, so let's treat this as annuity immediate. So the starting point would be 63. So for compound interest, for compound annuity, what we do is we get the net interest rate, which is I minus E divided by 1 plus E. I is 6%, E is 2%, is 1 plus 2%. So at this point, so at the value equals 1 divided by 1 plus E, A, N, J. So we have 31 payments, but you should evaluate at the new net interest rate, right? And right now you want to know, or Brian wants to know how much he needs to deposit at this time, or at the first day of his 25th year. So we know the PV. So let's put at. This will be whatever you get there, discount, right? So here it's 63. How many years in between? How many years between 24 and 25? 1 year, right? So it's distant. So it's basically the difference. So 63 minus 24, you will get 29 years. So I need to discount 39 years, not 29. So you need to discount by 39 years. Right? And when you discount, this is 1 over 1.06, right? You use your interest rate because the question says there is no inflation in between the current time and before his 65th birthday. We are almost done. The last one is a calculus question. So we have this payment. So first of all, we want to know the present value. And this continuous payment streams, it's from 5 to 10. The payment rate would be 1.8 t squared plus 6t. And now we just need to figure out the discounting. We want the present value to be at 0. Okay, so the difficult part is this. You need to further separate into 2 pieces because theta t takes form of, it has different form for t less than 5 and for t greater than 5, right? So let's copy first. Okay, for integral, I can separate. Okay, between 0 and 5, my force of interest is, well, there are quite a lot of zeros, plus 0.03 ds, so put s. Okay, and then I have another part I can separate because this is exponential function. Exponential of a plus b equals exponential of a times exponential of b. So here's 5 to t. Okay, but now my force of interest changed 0. Let me be careful how many zeros. There are 3 additional zeros. S squared plus 0.001 s ds. So this part is constant. Not constant, but it has nothing to do with t, right? So you can easily, let's call this 1, call this 2. So 1 is the integral part. So it would be 0.004 s squared minus 0.03 s. S goes from 0 to 5, right? You put everything in. I believe, if my number is correct, it should be negative 0.25. Now let's do the second integral. 5 to t, and oh, not. I don't need to write this. I can evaluate the antiderivative. Negative 0.0001 s cubic minus 0.0005 s squared from 5 to t. Okay, so I get negative 0.001 t cubic minus 0.00. There are so many zeros. My eyes are confusing. Minus becomes plus, so eventually you get 0.025. Do the computation. Okay, so here's E. So do the calculation, you get negative. Well, this part we can, let's flex this out. Constant, we can take it out. Zero, 2, 2, 5. Okay, so what I do is basically get this one. There are so many zeros I can factor out. There are 4 zeros, so it's 2 cubic plus 5t squared. Okay, this looks better. Okay, so we did one of these questions in the lectures, right? This is cubic plus square. Here is square plus t. So right, we just need to use something to replace this, right? Then we can see du equals negative 1 over 10 fourths. Here's 3t squared plus 10t. Okay, this is not exactly what I have, but it's very close. Let's divide by times by 0.6. Okay, then obviously I need to divide by 0.6. So it's 6,000 now. Then it becomes this, right? So with this in mind, not this. I need to change. So let's keep this. So basically you're supposed to plug 5 in for all the way for u, but let's temporarily leave them. Okay. So I know this is e u. Okay. The whole thing dt would be negative 6,000 du. Right. So from there, you should be able to complete this entire question. Right. That's the end. So I should end this video here.